Today we finish up the series of incremental programs we've been developing in order to create this simulation. In other words, today we actually create this simulation of the nested for loops and an animated demo. And this is mainly going to be a graphics video. The two main objects we're going to talk about are the LinearGradient and the fill rectangle. And the LinearGradient takes 4 parameters, 2 points and 2 colors. And basically, I don't know if you've dealt with linear gradients before, or radial gradients, or any of those, or any radial gradients, or any of those type of gradients. But the main reason I use them is I think they're really pretty. And a linear gradient basically takes 2 or more colors, and it starts with the first color, and then for a certain distance it starts to fade that color out and fade a second color in. So when you reach the bottom of the linear gradient, it's entirely the second color. So the 2 points define the start and end point of where this linear gradient is, and unfortunately it's an absolute position on the drawing surface. And the first color is the color that the linear gradient starts with, and the second color is the color that the linear gradient ends with. And then the other object we're going to look at or introduce today is the fill rectangle, and this has to exactly overlay the linear gradient brush, because we're going to use that brush to paint the rectangle. And it has the brush parameter, which is either going to be linear gradient or the background color to erase it, and 2 parameters indicating the upper left corner of the object, and then a width and a height of the rectangle. And the objects in blue here are ones that we've already discussed. The draw rectangle draws the outline of a rectangle that we use to indicate directories that are totally non-active. They're neither being copied to nor copied from. And the parameters of the draw rectangle are a pen as opposed to a brush. A brush is used to fill in objects, and a pen is used for outline or stroke type objects that are empty on the inside. And then it has a X and a Y to indicate the upper left corner, and a width and a height, exactly the same as the fill rectangle. Generally speaking, methods that start with fill are used to create solid objects that are filled in, and methods that start with draw are used to create outline objects that are empty on the inside and are just strokes rather than fills, as they say in Adobe Illustrator. And another method we looked at previously is the fill polygon, which we use to create the red and black pointers that point to the to and from directories. And that requires a brush, since it's a filled in object, and also an array of points, so you can have any number of points to create different types of polygons. And then the pen object we used requires a color and optionally a thickness, so the pen object is used in like the draw rectangle. And the solid brush object takes just a color parameter, and it is used in filled in solid objects like the fill rectangle and the fill polygon. And the graphics is the way we create a drawing surface. We initially created a panel, and then we created a drawing surface inside that panel. And the way we did that is we defined a graphics object called G, and then we set that equal to the panel name, and the method create graphics, the method of the panel. And finally, the point object was we used real extensively for the arrays of points that allow us to move things around in the animation. And the point object parameters are just an int x and an int y for the position of the point. And to sum up the main essence of how we get the animation to work, I have a statement up here that says putting variable rectangle information, pointer location information, linear gradient brush information, and corresponding arrays, so they can all be referenced with one number and all changed together as a group with just one number referencing them, usually the number being the primary index or the secondary index. This is sort of the essence of the secret of getting this animation to work. So if we look at the actual code behind of the actual of the final program, you see we have our finite state constants that define the four finite states, and then our system parameters that define what the first node and the last node is, and then our working state variables, which is the primary index and the secondary index, which are used to access the graphics objects and sort of tie all the different graphics objects together by being able to reference them with one number that associates all of them in that one group. And then we have the finite state automaton state, and we have our pen and solid brush objects, which was already discussed in our graphics object. And then we have our array of points that define the to pointer in the case of these 5 arrays, and the from pointer in the case of these 5 arrays. And then we have an array of pointers that allows us to access, using our index value, either the primary pointer or the secondary pointer. And now we add 3 new arrays. One is array of integers that is just the y value of the rectangle. Remember before we went through in a loop, if I can find it, went through in a loop and just wrote the rectangle starting with a x of 300 and a y of the iy times 100, and the iy went from 1 to 5. So this basically went from 1 to 100. Now instead of doing it that way, we're defining an array, because as I said in the description, we need to associate all these objects together with one index value. So these are the index values for 100, 200, 300, 400, and 500, which are the possible y values of the rectangles. And then we have 2 arrays of linear gradient brushes, which I was describing previously as going from one color to another and fading from the one color into the other color in kind of a very pretty way. And I just define these as empty arrays right now, but when we come down to our form load where we define all our initial stuff, these are defined in great detail. I have the LGB from, which is the linear gradient brush from for the from pointers, and I define the point that they start at, which is 300, 100, and the point that the colors end at is 300, 180. And this makes this a horizontal, or rather a vertical linear gradient, because it's going from a y value of 100 to a y value of 180. So it's going down the rectangle to fade from one color to the other. We could instead make this 300 to 380 and leave the y at 100, and then it would be a horizontal radial gradient. Or we could make this a diagonal and go from one corner to the other and create a diagonal linear gradient. So there's a number of possibilities of changing the points to changing the way the linear gradient works. And the from linear gradients all go from color red to color yellow. And then we do exactly the same thing with the 5 linear gradient brushes for the 2. but in this case the colors they go from are color blue to color green. And then of course we define our timer event for making the animation run independently without having to press the step button. And all the event handler for the timer does is call the step button press. So in effect the timer is pressing the step button for us. And then we get to our state methods, the 4 state methods associated with the 4 states. And where we used to just draw the rectangles with a loop, we're now going through and drawing them using the directory Y array, which goes 100, 200, 300 and so on. And we're taking Y from 0 to 4. And one thing we're doing in addition, we're setting the rectangle to the background color, and then we're drawing the rectangle. And the reason we're doing it that way is we don't know how we're getting into the initial state. We may be getting into the initial state from another state, and we need to erase where the background was before and put it back to just an empty rectangle in case we have a filled linear gradient in it. And then we're also erasing the pointers in case we came from another state. So we erase both the from pointer, or the to pointer, which is pointer primary, and the from pointer, which is pointer secondary. And the way you erase, of course, is just by writing the background color over them. And then we reset the system by setting the primary index to the first node and the secondary index to the last node. And we draw a rectangle at the primary location. But this time we draw the rectangle with a fill rectangle and first erase it using the background color, and then use a fill rectangle with the to color referenced by the primary index, and the directory Y with the primary index. So this basically writes a linear brush rectangle to this location, the location of the primary index, which is the first location set up here. And this actually does the pointer, the to pointer. So in a way these two should probably be together because they're more associated together, this one and this one. And this also is associated with it because it draws the pointer that's pointing to the rectangle. And then we do the same thing with the from rectangle. First we draw the from triangle for the pointer, and as you can see everything's tied together with the secondary index. And then we do a fill rectangle of the linear gradient brush of from, referenced by the secondary index, because these linear brushes are in specific places, and if you don't use the linear brush for that place in that rectangle, it won't work correctly. And then we use the Y, which is the only variable of the 4 coordinates. It's also referenced by the secondary index. And we set the state to decrement secondary. And then in the decrement secondary, we fill in the rectangle with a background color to erase where the previous secondary rectangle was. And then we fill in the triangle for the, in this case, from brush with the background color to erase that also. And then we do a draw rectangle with the black pen to redraw the rectangle of the directory we're leaving with just an empty rectangle. And then we decrement the secondary index and we fill in the pointer at its new location, the new secondary index, with red, so it moves the red pointer up. and then we fill in the rectangle at the new location with the linear gradient brush, the LGB from, referenced by the secondary index. And at this point we check whether we need to change state again, and this is identical to our change state code before. If we're at the bottom of the primary index, we switch to increment primary, but if we still have some room to go up, we stay in the decrement secondary state. And in the increment primary, we essentially do what I've been describing before. We overwrite where the rectangle was before, in this case for the primary index. This overwrites the primary pointer with the background color, and then we overwrite the rectangle we were before with the background color, once again using the reference to the directory Y. And then we draw a rectangle with the black pen to create an empty outline where we were before, not where we're going, but where we were before, and reference the directory Y with primary index. And then we draw a polygon of the background color where we were before with the secondary index, and draw a rectangle of background color where we were before, or rather do a fill rectangle where we were before with the background color. So this makes the previous rectangle disappear for the secondary index. And then we draw the empty rectangle outline with the black pen for the secondary index at this point. And so we've now emptied out the two rectangles of where we were before, and we set the secondary index to the last node and increment the primary index. So secondary index is resetting to the bottom and the primary index is moving down one. And then we fill in the 2 pointer with our black color with a fill polygon, and fill in the rectangle of our current rectangle, that's 2, with the linear gradient brush of 2, and referenced by the Y value of our primary index. And then we create our 2 pointer, or rather our from pointer, with the secondary index in red, and then create our from rectangle, which is also a linear gradient, with the linear gradient from referenced by the secondary index which is now at the bottom of the system, and the directory to draw the rectangle referenced by our secondary index of our directory Y's array. And then once again check whether we've finished the whole process and set the finite state to done processing, or we flip back to secondary processing to start decrementing the secondary pointer, because there's still some room to go up under the primary pointer. And then the done state basically just erases everything. It sets the primary pointer to the background color, and then it does a fill rectangle of the background color over the current directory, whatever it is, and then it does a draw rectangle of the current directory at the primary pointer, and the same thing, it fills in the background for the secondary pointer, and then fills in the background for the rectangle of where the secondary pointer is, and then it draws a rectangle of where the secondary pointer is. So that basically just ends up creating 5 empty rectangles by overwriting the current rectangles of where the primary and secondary rectangles were. And this could either be at the last position if we ran out of the system, Or it could be that we just hit the stop button. Actually, the stop button doesn't go to the done state, I don't think. I think it stays where it was. So forget about my saying that. And this, of course, the step is the hub method, or the traffic cop that redirects everybody. It's what gets called every time at every step. And it's either called by pressing the step button directly or by the timer calling it, in case of the animation. And in the case of the run button, if it says it's run, we start the timer and turn the text to stop. And if it says it's stop, we stop the timer and set the run button to run again. So if we press it again, it'll start the animation again at the point everything's at. The primary and secondary pointers could be at some variable state, like partially through going through the system. So we couldn't stop it and run it at that point. The system variables will remember where it is. So if we compile and run this, and if you just click on the background, it'll create it in the initial state. And if you press step, it'll start stepping through. When the secondary pointer reaches the bottom of the primary pointer, the system goes into increment primary state, and we now go down 1 for the primary pointer and start back at the bottom for the secondary pointer. And then when we reach the end of the system, we go into the done state, which is just the 5 empty rectangles. And if we step again, we're back at the beginning of the system. And if we press the run button, of course, it does this automatically. I actually slowed down the animation. It wasn't a half a second, but that was a little too frenetic. I felt like I drank about 20 cups of coffee. So now it just runs at a step per 1 second, 1 step a second. And I don't know, I may have said all I have to say about that. So you can stop it at any point, and the state variables remember where it is. So if you press run again, it just starts running from that point, which is something I said before. Well, I hope you enjoyed this series of videos on the graphics demo animation for the nested for loops. And I'd appreciate it if you'd subscribe.